How well do you understand the concept of joint variation as a topic in mathematics? In this video, we want to simplify the concept of joint variation using a simple question. Here is the question. This question was sent to me by one of our fans, and we are just going to provide an answer to it. The question is long, but I'm not going to read everything. However, I will read it as we solve. The video is a bit long, so I will implore you to watch this video to the end because it is interesting and educative. Most importantly, the last question, C part of the question. This is the most important part of the question, so you want to watch to the end to see the solution to that part. Let's dive right into it. The question says that we are given that the energy E varies directly as the resistance R. Let's write a mathematical representation of that. E is directly proportional to R. That's the first statement. The same E is inversely proportional to the square of the distance D. So we can say E varies inversely as D squared. Inverse is 1 all over D squared because it is the square of the distance D. This is a joint variation because it establishes a relationship between at least 3 quantities, and these quantities are E, R, and D. So it is a joint variation. Now we have 2 separate variations. We just have to combine them to form a single joint variation, and it becomes E is directly proportional to R and is inversely proportional to the square of the distance D. So this is the joint variation that took into account these 2 variations, direct and inverse, to form a joint variation. So this is the relationship we'll be working with. In mathematics, you don't solve with proportionality sign. So we are going to remove this proportionality sign and change it to an equal to or an equation. If we do that, we introduce a constant so that E becomes equal to KR all over D squared, where K is a constant is the proportionality constant that was introduced to change the proportionality sign to an equal to. Now, we are told to obtain an equation connecting E, R, and D. So we want to find an equation that connects E, R, and D. To obtain that equation, we want to know the value of this constant term, K. How do we get the value of the constant term? We are given some figures here to evaluate the value of K. E was given, R was given, and D was given. If we put the values here, we can make K subject to the formula and obtain the value of K, the constant K, for which this equation is valid. Then we can now write a relationship for this. Let's go on. Since we want to make K subject to the formula, we cross multiply. KR equals E times D squared, so that we have KR equals E D squared. To obtain K, we divide both sides by R, so that K will be equals to E D squared all over R. At this point, we put the values of E, R, and C, and that gives us K equals to 32 over 25 for E, times D squared is 5 squared because D is 5, and it is divided by R. R is 8. 5 squared is 25, so this can knock off this and we'll be left with 32. 32 divided by 8 is 4, so the value of K is 4. Now that we've obtained the value of K, we are just going to substitute it into this equation, and that will give us the equation connecting E, R, and D. That is the relationship. So if we put 4 here, the relationship becomes E equals 4R all over D squared. This is an important relationship that we will further use to solve A, B, and C. And we have obtained that. Now let's proceed to the first part of the question. A. Find the value of R when E equals 16 and D equals 3. We want to find R, so it is important to make R subject to a formula. To do that, we first want to cross multiply so that we can have 4R equals this. So for the A part, we have that A will be equal, for the A part, we have that 4R will be equal to E times D squared to give us E D squared. Since we're looking for R, we divide both sides by 4 to make R subject to the formula. So that R will be equals to E D squared all over 4. Now we can substitute values to obtain R. Let's go to the next page. This is the relationship. I've repeated it. This is the formula for R. We've derived by making it subject to formula. E is 16 and D is 3. Let's put the values. So R equals 16 times 3 squared all over 4. Then R becomes 4 times 9. 4 because 16 divided by 4 is 4. 3 squared is 9. 9 times 4 gives us 36. So the value of R is 36, and we are done with the A part. Let's go to the B part. The B part, we have to find the value of D when R is 5 and E is 5 all over 6. We are looking for D, so we need to make D squared first of all, subject of formula in this relationship. If you cross multiply, you can see that D squared can multiply E. If they can multiply, then they can be swapped. So we can put D squared as here as well. So for the B part, making D squared subject of formula, we just swap D squared and E, and we have D squared equals 4R all over E. At this point, we put in values. D squared equals 4 times 5 because R is 5, and is further divided by E. E is 5 all over 6, 5 over 6. If we change this division to multiplication, what happens? We invert this fraction. The 6 comes to the numerator and the 5 goes below. Now 5 can cancel out 5 and we'll be left with D squared equals 4 times 6. Remember, we are looking for the value of D and not D squared. So what do? We take the square root of both sides, so that D will be equal to the square root of 4 times 6. The square root of 4 is 2. The square root of 6 is an irrational number, so we can say the answer is 2 root 6. So that is the B part of the question. D equals 2 root 6. You can decide to take both the positive and negative value of 2 root 6. That's fine. But this question is only after the positive values, which is the principal square root of 24. Now we are done with the B part of the question. Let's move to C, the highlight of this video and the interesting part of it. So we have this relationship written again, and in the C part, we are told to find the percentage increase in the value of R when each of E and D increases by 3%. Since we are looking for percentages increase in R, I have made R subject of formula. So the C part, we make R subject of formula. I have to write this down because we've already made the subject of formula in the A part already. So I just copied it from the A part down here. Now that we've made R subject of formula, let us find the percentage increase in R when E and D increases each by 3%. Let's get some concept clear. When I say 100%, what comes to your mind? It means complete. It means that is the full value. If the full value or the complete value increases by some certain amount, say 3% as in this question, we can say that the 100% can now be represented as 100 plus 3%, and that is 103%. The reason is that 100% is complete, and that increased by 3, so we add 3 to it to give us 103%. If we write 103% as a fraction, we can say 103 divided by 100, and that is equals 1.03. What it means is that if something increases by 3%, we can represent that as 1.03. Now, let's bring it into this equation. E has increased by 3%, D has equally increased by 3%. So in the place of E, I am now going to write 1.03E because it has increased. In the place of D, I'm now going to write 1.03D because it has also increased. Remember the square. At this point, we solve further. Everything is divided by 4 rather. So we have 1.03E times 1.03 squared times D squared. Remember the square distributes across 1.03 and D, so we can split it like this. Now we have 1.03 here, and we also have 1.03 here. So both of them can combine to give us 1.03 raised to power 3, because 1 and 2 added up gives us 3, according to the law of indices. And we have E times D to give us D squared all over 4. Now take a look at something. 1.03 squared will give us 1.093, and we'll be left with E D squared all over 4. Compare this formula to this formula, and you'll find out that the only difference there is 1.093, which represents the increase in the percentage. So let's look at something carefully. If 1.03 signifies 3% increase, definitely 1.093 will signify 9.3% increase. And that is the answer to the C part of the question. Very simple, straightforward, and I believe you enjoyed this video. If you did, then solve this simple one, read the question, get the answers, and put it in the comment section. I'll be right there waiting for you. Once again, thank you for staying to the end of this video, and hope to see you in our next video.